number 4. So this time we're looking at 3 coin tosses. We have 3 versions of Tom here. So again, we're talking about a fair coin toss. We want to look at the following probabilities. The chance that exactly 3 heads comes up. So exactly tossing 3 heads, and the probability of tossing more heads than tails. Okay, so each of these is independent of each other. So you get tails, 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 heads. Right, so and you can have the first toss on 1 result in heads or tails. Then we have the toss on 2. Result in heads or tails. Then we can have the toss on 3, the third coin, result in heads or tails. Heads, tails. And again, each of these tosses is independent of the others. So if you trace down here, this you get 3 heads. This you get heads, heads, tails, so 2. This one you get heads, tails, heads. So that's 2 heads. This one you get heads, tails, tails, so that's 1. This you get tails, heads, heads. So that's 2. This one you go tails, heads, tails. So that's 1. This you get tails, tails, heads. So that's 1. And this, the last one is tails, tails, tails. So 0. Okay, so the probability of tossing exactly 3 heads. So again, X can be 3, 2, or 1 here. It's useful probably to make a distribution for this one, just up in the corner. So we can have X can take 0, 1, 2, or 3, and then we're curious as to what the count. We should do count for this. Count. Okay, so for 0 we get 1. For 1 we have 1, 2, 3. For 2 we have 3 2s. And for 3 we have 1 possible outcome. And again, there are 8 total possible outcomes here. So for tossing exactly 3 heads, we can get 1 out of 8. And for tossing more heads than tails, so that's 2 or 3. So that is X greater than or equal to 2, which would be probability of X equaling 3 plus probability of X equaling 2. Do it that way. So that's 1 and then 3 here, and each of these is out of 8. So that is 4/8, which is 1/2.